Is it a little bit easier to see? Okay. Because here, like I know that my back sometimes, so this would, it's better. Okay, you guys ready? Can I start playing? Sure. Go, team. All right. First one's easy, right? Why? Why? It's an odd function, so what's below and above? Good. How about number 52? 1/4.
I separated it.
Oh, I see. Yeah, because 3 is just a constant, right? And so you can just think about y equals 3 from 0 to 1. So you can go ahead. Technically, without even anti-deriving, you could just be like 1 times 3, that's just going to be 3. And 3 plus 1/4. Now, what if the interval was 0 to 2, 0 to 5? 0, now, this would get messed up, but wouldn't it just be 3 times 2 or 3 times 5 for this little area? Because it's the constant height, and then, the constant height, and then whatever the base, the x interval is for any constant. Which can also kind of help us with this one down here, right? I know, I'm jumping around, but these two are super similar because this would be a height of 1, a base of 1, so that's just going to be 1 minus 1/4. True? True. Oh, I'm just sticking it to the man. But yeah, that's fine. That would end up being 13/4 and then 3/4, right? Anyway, let's tie these two together, right? So what's this one going to be? What's it going to be? Oh, no. Sorry, I thought you said something different. I didn't know why. Yeah, 2/4, 1/2. Why? Absolute value on the inside. Absolute value on the inside. Now, I know. It ends up being the same thing in this case. I just want to make sure that you guys understand. Absolute value on the inside, what does it actually do? Does it flip this guy up? No. That's absolute value on the outside. What does it actually do? It takes that guy over. The one that you guys, I don't know, the one that I think makes the most sense is what if you have a parabola that's been shifted over? For instance, something like this. There you go. So we can make it something like y equals, I don't know, x minus 2 squared plus 1. That would work, right? Shifting 2 right and 1 up. If I was to graph g of x is equal to the absolute value of x minus 2, absolute value on the inside, not on the outside, what would that graph look like? You take what's here, and then what do? Because the negative x's no longer have any identity, because the negative x will behave just like the positive x's. So what was going on, the positive x portion of the graph will be mimicked on or for the negative x's, what they used to be. It'd be a mirror image. So it's not transforming this at all. It's a mirror image of the positive x portion of the graph. And I know it didn't make any difference in this function in the sense of this is the exact same thing as this. But either way, I just wanted to make sure that you guys knew what that actual transformation was. All right, we've avoided 53 enough. What's going on in 53? U is equal to x minus 2. So we could go ahead and make this, right? The integral from u cubed, I said from, sorry, the integral of u cubed, and then derivative of u is just 1 dx, right? So then du. What would my bounds be? 2 minus 2 is, 3 minus 2 is. Remember your u bounds. Remember your u bounds. We had to find u of 3 and u of 2, which is 1, which is 0. It's the exact same thing as the beginning. Dun, 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 dun. Okay, number 56. I can still make you a couple times. The same thing? So Aryan made the hole inside a U? Can you do that? So now what?
Oh, because you can't do that because of the. That should be 1/4 times by x over x, right?
Now Aryan did think about the u's and the u bounds, true? So plugging in -1 would be 0. Plugging in 2 would be 1. We would have u cubed. Then we would have x over absolute value of x du. Well, I wouldn't leave it with x's, right? So how could you go back to u's? Yeah, you could do that. Some of you are like, oh no, integration's coming. What about the top? Because you still need x, but without an absolute value. Go to your piecewise. Oh, you guys, you hate piecewise functions. Why? Go to your, no, the only way to get to x is to go to your piecewise, right? Who is the absolute value of x? Okay, changing colors. Couldn't we say that u is, right? Couldn't we say that u is a piecewise function? True or false? Absolute value is just a shortcut of a piecewise. Come on, we know that by now, right? Okay. So when is this going to be just x minus 1? On the right side, aka when x is greater than 0, true? Okay. When is this going to be negative x minus 1? When x is less than 0. Good, just based on, like, right, positive numbers stay the same, negative numbers flip. Okay. How can we say which one fits in this case? Look at the boundaries. Look at the boundaries. It's for positive values. Wait, could we have done that back here and not even had to worry about it? Anyway, so awkward. Well, the U-sub was still probably technically important at some point. However, I probably would have actually done it here instead of here. I would have thought about my x's to begin with, and you would have made the absolute value be just regular x, so it would have reduced away. You wouldn't have even had to have thought about U-sub. Does that make sense? Some of you yes, some of you no. So what if I did this instead, and you're like, oh, I don't know how to get rid of them. Is that better? Did anybody get this and be like, or look at it and be like, who got a little confused when you looked at that? Okay, cool. So let's just do this. So if we just do this, right? Stays the same, opposite. When x is positive, when x is negative. What are my x's? I guess it gets a little more confusing because then I have the -1 to 2. Maybe you did have to go to use, which makes sense with the U sub. That's annoying. I just erased it. Oh, undo button. Okay. Let's just go back here. Yay! Okay, go team. Stink. What's on the positive side gets reflected on the negative side. Do we really have to go back to that? Because then the x's do go from -1 to 2. We could split up the integral, but that just got a whole lot worse. Well, I was thinking the other way of doing it is that we could just think about x minus 1 cubed. And then whatever's on the right will be reflected on the left, but for only a portion. So we could go from like 0 to 2. And then from negative, oh, we do have to split it up no matter what we do. Okay. So if we split up from -1 to 0, then from 0 to 2, from -1 to 0, the x is, oh, can I do that? Is anybody following my logic right now? Hold on, let me write it out. Sorry, because you don't know what's going on in my brain. I think this works. What'd I just do? At this, yeah, I basically went to the piecewise function using the original and didn't even go to use. Sorry, Aryan, I tried to do the u thing. I just don't think it worked. I think it would have been simpler just to take the absolute value of x as it is. Aren't we learning more and more, though, how to deal with absolute value? This is like the 3rd time we've seen it this year, which is a good thing. Ah! It's because you're not as familiar with it. Well, okay. But it works now, right? Because we're making the absolute value what it would be for any negative values, which would be -1 to 0. And then we're making the absolute value what it would be for any positive values, so 0 to 2. And then we can go ahead and consider what we have. So on this one, I mean, still ultimately you end up doing u bounds. But now it's a whole lot simpler because now we're going to end up with u cubed. Derivative of x minus 1 is just du, no big deal. The bounds are going to be 2 minus 1 is 1, 0 minus 1 is -1, which we already talked about, number 51, which is just going to be 0. And then over here, we're going to go ahead and have u cubed. Ooh, but we're going to have a negative, right? Because the derivative of -x minus 1 for our du. And then what would my bounds be? What's -0 minus 1? And what's +1 minus 1? Because the negative, well, we can say it's flipped. Either way, you can bring the negative in and flip the bounds, or you can flip the bounds and bring a negative out. What ends up happening?
It's actually horrible. The answer's B. Oh my gosh! Wait, why is it should it still be negative? Or does a negative?
Oh, when you flip the bounds, remember? Becomes a negative, and a negative times a negative is a positive. The integral from b to a is negative the integral from a to b. Going backwards is negative, going forwards is positive.
1 to 1, but you could just write it as 0 to 1 because that's what it really is? Or?
Oh! Stink. I didn't realize I didn't rewrite it. My bad. Hold on. I didn't rewrite it. So it'd be -1 to 0. There we go. It's still 1/4. Because remember, for the odd function, it's going to be a negative, and a negative times negative is a positive. But my logic getting there was flawed. Thank you, Aryan. All right, guys, let's go ahead and grade. Ooh, look what section 6.3 is, though. No, pause. For the AP, is it helpful to think about what if we couldn't touch the x cubed? Yeah, it's super helpful. They would have made that an f of x, and it would have been an f and an f and an f and an f. Not like an f as in a grade, but an f as in a function. But where do we get to go in section 6.3? Aryan, look. What's your favorite? Yeah, no, we are going to grade. I was just showing you that we get to anti-derive in 6.3, which is our favorite. Here we go. Section 6.2, number 4. Come on, you guys had to at least kind of like this homework, though, right? We were using the Riemann limit definition of an integral to rewrite. Then we were able just to use geometry to say, hey, a constant base times, or sorry, a constant height times the base. That was fun with radicals and all. Number 18 was just a triangle, so 1/2 base times height. Would have been a lot easier than trying to anti-derive that by hand with an absolute value. Ooh. Limit definition of an integral, just rewriting. Height times base, height times base. 1/2 base times height, which is just 1. Number 26, 3t is a line, so if you set it up, it would have been a trapezoid. B minus a is your base. Height 1 is 3b. Height 2 is 3a. You could write it either way. Oh, they let you integrate in your calculator? Spoiled rotten. You're using your calculator. What does your calculator do? It doesn't do that. What's it do? You know how to integrate on your calculator. But now you know, just go do the integral in the math menu. It used to be FNINT, function integrate, and I think maybe it's a Casio, I don't know, something. 46 is true. 46 is true. 48 is D, and 50 is A, and praise the Lord, we're done. 26? Did you guys get D and A first? D and, never mind. Thank you. Thank you for that. Mrs. Leon would be proud. Actually, Mrs. Regan would be proud. Which one? Number 26? Oh, there he is. Here. Anybody have a question on 26? Because I helped someone with that last week. 30. Use the integral button in your calculator. Be gradient mode. Because int is integrate and n is numerically integrate. I think that's what it is, numerically integrate. This one, 3t, has an intercept at 0, up 1, 2, 3, over 1, 1, 2, 3, over 1. But it doesn't actually tell me where to stop, so I just know it's going to be this. I know it's starting at a. Didn't it say something like a is greater than 1 or something like that? A was somewhere removed. I don't think a was 0. Was it? Oh, in between 0. Okay, we don't know exactly where a and b is, but we know it's there. If we're trying to find the area, can't we do 1/2 base times height 1 plus height 2? My base is going to be, well, whatever that difference is, so b minus a. My height 1 is going to be the height at a, which will be f of a. Plug it in, plug it in. 3 times a is 3. Well, hold on, that's the shorter height, but either way. And then the height at b, whatever that is, plug it in, 3b. Dun, 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 dun. Okay, what else? Yeah. Okay. Any other ones, evens or odds? You'll ask me later for a stamp if you need it. Okay, section 6.3, let's go have fun. Whoo! Do we need to write them all down? I don't know, maybe not. Do you want to take a picture just in case you might need to refer to something? Yeah. I copy and pasted out of there. It'll be in the section. Definite integrals and antiderivatives. My distracted ones, we're going fast. We have 10 minutes. Integral from a to a, it's 0. Integral from a to b plus b to c is a to c. Integral from b to a, oh, it's opposite, negative a to b. If there's a constant, we pull it out. If there's a negative, we pull it out. If there's a sum or difference, we split it up. Ooh, what's new? These two. Max, min, inequality, and domination. Oh, that's an integral property? We missed out last year. Isa, missing out on domination. Well, I don't know. It's kind of cool. So proud of you all. So proud. Okay. What's the whole idea of the max-min inequality? Can you guys tell? Looks to me like a smaller rectangle and then a bigger rectangle. Wait, how does that make sense? Smaller rectangle and bigger. It's area. Can't we always close in area within a largest and a smallest? Yeah, the word. Where's additivity? Oh, additivity, that's just, what did we call it last year? Did it have a name? I don't think it did. Additive property. But this one is a rule, so the additivity rule. rule for additivity. Maybe that's a better way of putting it, because additivity isn't an adjective. It would be a noun, right? Additivity. Guys, this whole max-min inequality thing has shown up on AP questions in the past. It's a way of estimating or approximating. In that you can do like a, I don't know if you say a lower bound, but if you find the minimum value of a function, you could find a minimum rectangle. And if you found the maximum value of a function, the maximum height, we could find the maximum rectangle. So we could say basically like a lower bound or rectangle and an upper bound or an upper rectangle. And we know the integral is going to need to be within those two. I forget what question it was last year. I think it was an AP multiple choice where we used that as far as like a lower rectangle, upper rectangle, estimating in between. But that also kind of has to do with MVT for integration. We just haven't really gone over it yet this year. As far as there exists a perfect rectangle such that it's the same. And that perfect rectangle by IVT must be in between the lower and the upper. Anyway, that would be the logic behind. Domination is talking about a function whose y values is always higher than another function's y values. And it's basically saying, well, if its function values are always higher, then its integral is always going to have to be higher. It's always going to dominate. And a specific application to that could be, well, if all the y values are positive, then the integral is going to have to be positive wherever you're solving. But as soon as you introduce, ooh, there's a life lesson in this one, negativity, I mean negative values. Wherever you introduce negativity, I mean negative values. Then you're not exactly sure whether or not it will maintain that positive nature, right? Oh, it's getting going to chapel on this one. Anyway. I know, I was like, oh, we could definitely go into that. And maybe the application in chapel isn't necessarily to get rid of all of your friends and then be alone until you magically find perfect new ones, but to just consider what kind of friend should I be? How am I affecting the people around me? And the bigger question of, do I have people in my inner circle that are supporting me in the right things? And if not, are you looking? Are you praying? Are you desiring? You have to start with the desire. Anyway, domination, max-min inequality. You guys got it? Oh, picture. Anybody else need a picture? Or look in the book? Issa's a fan of that one. He's over there chilling. Digging deeper. We have to dig deeper? That's a life lesson too. What's going here? Well, wait a minute. If you're going from... Hold on. What is it? A plus b of f of x dx plus b to a of f of x dx? You go forwards and then you go backwards. Well, I don't think you covered anything, right? How can you prove that it's 0? I totally agree.
Because when you do the reverse of the bounds, it's just a thing negative, right? So that's just negative a to b.
One way is the additivity one, but then the other way is what Aryan is saying, which is, oh, hey, from b to a, isn't that the exact same thing as negative the integral from a to b? Remember, when you go undoes, or it shouldn't say undoes, that's inverse. It covers the opposite area, opposite displacement. I don't know. So whether you think of this guy as the negative, they cancel out, or whether you think about the additivity rule from a to b and b to a is just going from a to a. Oh, that's a 0. Ooh, what do you guys see that might come back up again? See what I mean? The AP is going to give you F's and G's, and you're going to have to use the clues. Will some of them get interesting? Yes. Do we have time to do it right now? Probably not. Is this going to be maybe opener for tomorrow? Let's have fun with that and see how you guys do. But as far as notes, let's keep going with average value. Ooh, average value. That's an important one. Well, if they say average value, hopefully you know exactly what to do. When do we use the integral to find the average. Now, do you guys literally have to be able to connect the Riemann sum to the integral? Not technically. But if we're finding the average of an arbitrary function, what I would call an average value, not average rate, are we supposed to be doing anything with finding slopes, whether with derivatives or with s sub b minus s of a all over b minus a? No. If we want the average of something we're being given, what we need to do is integrate, basically accumulate all of the change that happened. Integration accumulates all the change that happened. Integrate the rate or accumulate all the change in the original quantity that happened and then divide it by the interval b minus a. Do you need to write down all the Riemann sum stuff? No, not technically. But this is all where it comes from, is partitioning a to b into all these different little subintervals. Trying to average is dividing by the number that you have, which is where the 1 over n comes from. But we're not going to go super crazy as in like setting up the definition of where average value comes from. But it is the idea of accumulating all of the change that occurred, which means I need to integrate the rate and then dividing by the b minus a interval. So if we were integrating velocity measured in feet per second, we would get back to an accumulation of feet, the feet that changed, and I would divide by the change in time to get my per second. I have to make my feet per second. I can't just use what they give me. And I definitely can't go putting feet per second into a slope formula, or I'll get to feet per second squared acceleration, and I'm way far off where I want to be. Remember, average value versus average rate, it's all based on what I would say. What are you dealing with? What are you dealing with? What are you being given? What are you trying to find? That's what leads us to average value. Oh, look at this guy. 2016, question number 5. The funnel problem. I know. This was definitely the one that was most tweeted. I don't know if it was most. Yeah, it was. Yeah, it was most tweeted after the AP this year, and it was right before you guys. Where did it get hard? Technically, it probably got hard for most of them, right around letter B. Everyone was mad about, we never learned how to find the volume of a funnel. Did you learn how to find volume using cross sections? Yes. Anyway, coming back. But I'm not asking you to do B or C. What am I asking you to do? What does A say? Find the average value of the radius. Who's the radius? Oh, so all I have to do is just set up the integral 1 over 10 minus 0 times the integral from 0 to 10 of 1 over 20 times 3 plus h squared dh. What question is this? Number 5. Would you have been able to use a calculator? No. Would you have stuck it to the man after solving appropriately far?
Yes.
Hopefully, yes. Would you have gotten that part right? Hopefully it says average value. It's glorious. What did everybody hate? Letter B. But we're not doing that today. We have not reviewed volumes yet. Oh, hey, look. Dun, 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 dun. Look. Oh, my goodness. Stick it to the man. Anyway.
I was supposed to do my comment up yesterday.
Hey guys, this is awkward, but we're still in CalcBC. The bell hasn't rung, and I have more notes to go over. So, MVT for integration. Whoa, whoa, whoa. Who's this guy? Oh, average MVT. Average equals, interesting. Is it the same thing as average rate equals instantaneous rate? Well, kind of. Average value, maybe of velocity, average velocity, depends on what your quantities are. But, as I said a little bit earlier today in class, it has something to do with there exists a perfect rectangle, because we can rearrange this to be f of c times b minus a is the integral from a to b. Who knows how we'll see it? Oh my goodness, what's an application of that? Is that FTC part 2? Pause. Our book labels the FTCs backwards of last year. So just be aware, if something comes up with d dx of an integral or f of b minus f of a, just call them all FTC, and let's not stress about part 1, part 2. We're just going to be like FTC, yeah, whatever one you want to call it is the one we're talking about. Some people do chronological order, and some people do, I don't know, usefulness order. All right, cool kids. With that, tackle 6-3 for tonight. I'll see you guys later.